Arduino for beginners, crystal ball. This series is something you don't want to miss. You want to watch this video all the way through. There's a little something for beginners, and I would even say people who are a little bit more advanced with Arduino. Like I said, you want to watch this video all the way through. Make sure you don't miss anything. I'm Ebonygeek45, and I would say make sure to hit your subscriber button. I would say smash that subscriber button. Subscribe to my channel. Hit that notification button so that you will be notified whenever I do a new upload. Enjoy the videos and take your time going through them so that you understand exactly what's going on in the videos. And here we go.
Hi, my name is Massimo Banzi and I like to make things. Welcome to another Arduino tutorial video. Today we're going to build an electronic version of the Magic 8-ball. So this is a simple device with an LCD screen that provides a different answer every time it's being shaken. So let's try. Look at this. 8-ball says outlook good. So how does this project all work? We have a sensor, which is the tilt sensor over here, that contains a small ball sitting on two contacts. When the tilt sensor is vertical, the ball sits on the contacts, closes the circuit, and acts like a push button that's being pressed. When you shake the board, the ball bounces off the contacts and opens the circuits, and it's almost like it's like when you release your finger from a button. The data from the sensor goes into the Arduino, and there's a software that detects that you're shaking the Arduino and picks a random answer and displays it on this LCD display. It's fairly simple to connect an LCD screen to Arduino, and this one in particular because it's a character-based LCD. So it contains already electronics on the LCD module itself that can receive data from the Arduino in terms of character codes and then display the characters on the LCD screen in the right position. Let's have a look at the circuit. So we have the LCD module here. We are bringing 4 wires from 4 Arduino pins to the LCD modules. Those 4 wires carry the data from the Arduino to the LCD screen. Then we have an extra 2 pins connected to the Arduino board that are used in the communication between the Arduino and the LCD screen. Then we power the LCD screen. You see there's a red and a black wire coming from the plus and minus rail. Then there is this potentiometer. The potentiometer here is used to generate a voltage between 0 and 5 volts that is applied to the contrast pin. So if I start turning this potentiometer, you can see that the contrast on the display changes. So we have to tweak it until the value makes the display work properly. So this can be tweaked depending also on the angle that you watch the LCD. So as I said, data, a couple of control lines, power, contrast, and this is all we need in order to connect to the LCD module. Here we have the tilt sensor is wired up exactly like a regular push button. So we have one leg of the tilt sensor is connected to a resistor to ground. The other one is connected to 5 volts, and the place where the resistor and the tilt sensor connect is where we connect a wire that goes to an input on the Arduino board. Then the Arduino can read if the tilt sensor is connected or not. So when I shake like this, Arduino detects the shaking and changes the answer on the screen. So to recap, we have a tilt sensor connected to the Arduino, and we have 6 wires coming from the Arduino and connecting to the LCD screen. The data that goes from the Arduino to the LCD screen is actually represented as 8-bit numbers. But we wire up only 4 wires, and we use a special mode in the LCD displays that carries 8-bit data at 4 bits at a time. So using the LCD would require you to write quite a lot of code, but luckily there is a liquid crystal library inside the Arduino platform that allows you to control this class of character LCD displays in a very simple way. So now we're going to have a look at the code and we're going to figure out how everything works. Let's look at the code. We start by including the liquid crystal library. So we use #include liquidcrystal.h. This can be done actually by selecting appropriate import library menu from the IDE. And then once we have included the liquid crystal library into our code, we have to tell the library which one are the pins that are connected to the LCD. So we specify 12, 11, 5, 4, 3, and 2. These are the pins that we're using here to convey the 4 pins of data, then the RS and RW pins that are used in the handshaking and in the communication between the Arduino and the LCD. Once we have done that, we are ready to use the LCD screen. So we define another constant, switch pin equals 6. This switch pin, this pin number 6, is where we connect the tilt sensor. Switch state, again, is a variable used to store the state, the current state of the tilt switch. And then we have another variable called pre-switch state. And the fact that we need to store the current and the previous value of a certain switch will become clear later. Then we have another integer variable called reply. So let's look at the setup function. We open the communication with the LCD screen by using lcd.begin. And then in the begin function, we specify 16 and 2 to tell the library that the LCD that we are using has 2 lines of 16 characters each, because there are many different types of LCD screens like this. So when we initialize the communication, we have to specify the size of the LCD display. Then we use pin mode to tell Arduino that switch pin is an input. And then we use lcd.print to write the first line at the top that says ask the. Then we use another interesting function of the LCD library, lcd.setCursor. SetCursor allows us to specify which column and row we want to start printing from. So I can move the cursor anywhere on the LCD display by specifying the position. With the last line in the setup, we print the second line on the screen. So lcd.print magic 8 ball. So to recap, in the setup, we're basically opening the communication with the LCD screen, preparing the pin, a switch pin to be an input, and then we print on the 2 lines of the display, ask the magic 8 ball. Then let's get into the loop. So the first line in the loop stores the current state of the switch into switch state by doing a digital read on the pin. And then we say, if switch state is different than previous switch state, and this if statement, it's used to figure out if the state of the button has recently changed, because we want to provide a new answer on the screen only when the state of the switch changes. And the state of the switch changes only when I shake the circuit and the ball inside the tilt switch jumps up and down. So if switch state and previous switch state are different, then we can move on and we can say, if switch state equal low, then actually generate a new reply. So we start from clearing the display by using lcd.clear. Then we generate a random number between 0 and 7 that gets stored into the reply variable. Then we set the cursor to 0, 0. So the top left corner of the screen, we say, we do LCD print 8 ball says. Then we set the cursor on the second line of the display by doing LCD set cursor 0, 1. And then we use an instruction called switch that basically allows us to run different parts of code depending on the value of a specific variable. In this case, we switch based on the value of the reply variable. So if the number that was generated randomly is 0, we are going to lcd.print on the screen the word yes. And then we have a statement called break that tells Arduino that we're done executing the code in that section and we want to exit the switch statement. And then for every particular value that the variable can assume, we have 0, 1, 2, 3, and each one of them corresponds to a message. So we have unsure, ask again, outlook good, no. Once we are done going through the switch statement, the screen will have an answer. And then at the very bottom of the code, we have one line that says prev switch state equals switch state. So the current state of the switch state, is not current anymore. At the end of your code, that's old. It's the previous state. So we store it in previous state, and we go back to the beginning, where the first line is taking a new value into switch state. And this allows us to detect every time the value changes. We got to the end of the code, and this is the end result. So I'm going to press the reset button so we can start the code from the beginning. So you see, ask the magic 8 ball. So I'm going to shake this, and the magic 8 ball says yes. So I have to ask a question. Was this video cool? Yes. The magic 8 ball says yes. So I think this is a very good conclusion for this video. I hope you enjoyed the video. And remember, you have to build this tutorial, you have to hack it, and you have to share the results on the internet because Arduino is you.
And this is Ebonygeek45. If you didn't understand anything in the video, make sure to put it in the comments. I'll definitely get back to you with an answer. If you haven't subscribed to my channel already, make sure to smash that subscribe button. While you're at it, make sure to hit that notification bell so that you'll be notified whenever I upload new videos. I want to thank you for subscribing ahead of time, and don't forget to subscribe. As always, this is Ebonygeek45. Happy tinkering, happy coding. Today is a great day to learn something. And bye-bye.